Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, let us solve the next question, question number 38, and we'll see, so far we have done up to 37. Let's see what is question number 38 and solve it. Students, let us start question number 38. Of JEE Advanced 2014. Now the question says 4 combinations of 2 thin lenses. These are thin lenses, 4 combination. One is this, another is this, another is this and that. Here the first case we have got 2 convex lens. Here there is planar convex lens, 2 planar convex lens. Here there is 2 plano concave lens, and here is 1 convex lens and 1 plano concave lens. These are the 4 combinations. The radius of curvature of all curved surfaces R. So everyone is having radius of curvature R, and the refractive index of all the lenses is 1.5, of which it is made up of, that is, suppose that it is made up of glass, so refractive index of glass is 1.5. Match lenses combinations in list 1 with their focal lengths. So this is the list 1 with their focal lengths, we have to find in each case. In list 2 with their focal length in list 2, so we have to find focal length and match with the corresponding options in the list number 2 and select correct answer using codes. So first of all, we have a lens formula that is called lens maker's formula. So we must know what is lens maker formula. So first of all, we write lens maker's formula. What is that? That is 1 upon f is mu minus 1 This is lens maker formula and we have to use it, and combination of lens, another formula we are going to use. This is the first formula. Another formula we are going to use, the combination of lenses. The focal lengths are equivalent focal length. For 2 lenses we have to use this formula. This f1 and f2 with sign we have to put it. With sign. Here also we must keep in mind that while using this formula, we have to use sign convention. Now, first option, the first case we will consider from list 1, that is the P. Here we have got 2 convex lens like that, double convex lens, and we have to find the focal length of this combination. First of all, if I think of a single lens, what is this focal length? For a single lens, if I have of refractive index 1.5, here it is 1, this is the refractive index of glass, this is the refractive index of air. So the lens is suspended in air, this side and that side, the refractive index is 1. Now I have to find the focal length of a single convex lens, that is mu minus 1, that is mu z a minus 1 1 upon R1 minus 1 upon R2. This is the refractive index of this lens with respect to the medium, which is air. If the lens is suspended in water, then we write the refractive index of glass with respect to water. But here it is air, so it is like this is 1.5, that is 3 by 2 minus 1. This is given 1.5, which is 3 by 2. 1 by R1. Each one having radius same. The radius of curvature of all is R. So here is R. I'll write 1 upon R. And this one is R1 and this one is R2. This one is positive because this is lying to the right of this, so radius of curvature is positive, and this one is negative, so this one will be negative, so minus of R. If you solve this, this is 1 by 2 and this becomes 2 by R, so it is 1 by R. 1 upon F is 1 by R, so F is R. So for a single convex lens, we have focal length equals to R. So now I'll use a combination of focal length formula for this case. 1 by F equivalent, supposing that these two are having same focal length, this is also having focal length F, this is also having focal length F. So equivalent formula is 1 upon F1, that is F, plus 1 upon F. This is 2 upon F. So F equivalent equals to F divided by 2. Cross multiplying, F equivalent to F divided by 2. F is R, so it is R by 2 because F is R. From here, so F equivalent is R by 2. If I see that the R by 2 is here, so for P, this is option number 2. So for P2, we have got two choices, either this one or this one. So we do either 2 or 4, one of them is correct. Then we do check for another option Q. Let us check for Q. Now the option Q says the combination is like this one and this one. You can see here the combination is like this, two plano convex lens. So double lens and plano convex. Plano convex lens, if I want to find for any single plano convex lens, what is the focal length? This one is R1, this one is R2. This one is a plane surface, so R1 becomes infinity and R2 is your minus R because this is lying to the left. If I compute this, lying towards left of this, so it is minus R. If I substitute this value in the lens maker formula, 1 by F is 3 by 2 minus 1 as usual in the last formula that we used to solve, into 1 upon R1, that is infinity, minus 1 upon minus R. So this is 1 upon R, this is 1 upon 2, 1 upon 2R. So F comes out to be 2R. So for plano convex lens, so we'll use the focal length 2R. Now what is the combination? If you look at the combination, this is the combination of these two lenses. You must also remember that whether you take this one or this lens, if I take this one also, then also the focal length is equal to 2R, because this time this will become positive and this will become 0. This will become positive R, this will become 0. So again it is the same value, F equals to 2R. Now So whether I take this side plane or that side plane, the focal length is f equals to 2r. Now I have the equivalent focal length, that is our aim to find the equivalent focal length, that equals to 1 upon f1, that is f plus 1 upon f, but f in this case is 2r, so it is 2 upon f, as you can see here, that is 2 upon f is 2r, f is 2r, I substitute here, and I am getting f equal to this, 2 to cancels, and f equivalent comes out to be r. If f equivalent comes out to be r, then I will see the option that in this combination r is the answer. If I see that, then 1 upon 2 upon f, 1 upon f r, but there is no r. Surprisingly, it is 2r, 2 upon 2r, f equals to r, f equals to r is there. This one is f equals to r, but this should be smaller, this not be capital R, this should be smaller, so this is correct. So for q is a misprint, it should be smaller, so it is q4 is the answer. That means p2 q4, p2 q4 is this one, here it is q1, so this is not the answer, this should be the answer, but we have to find all the options. Okay, we have to find all the options because that is the requirement to find. Let us find the other options as well. If I see the option number R, let us see the option number R. What is that option number? This option R is a combination of two plano concave lens. Is a plano concave lens. You can see here. So option number R is like this. It is a combination and you have to find the focal length, equivalent focal length of this combination. Now for any individual plano concave lens, the focal length you have to find using that lens makers formula. 1 upon f is 3 by 2, that is given in our question. 1 upon r1, this is our r1 and this is our r2. R2 is infinity, r1 is negative r, because this is lying to this side, so it is negative. So 1 upon r1 is minus r, minus 1 upon infinity, this becomes 0, this becomes negative, so it is minus, this is half, this is minus r, so 1 upon minus 2r. So from here I write f equals to minus 2r. So each such lens has focal length equals to minus 2r, and we have two such lenses. The combination of these such lenses by equivalent focal length, we have the formula 1 upon f1 plus 1 upon f2. This equivalent focal length, 1 upon f1 is minus 2r, so it is 1 upon, that is I will write 1 upon f plus 1 upon f, that is 2 upon f, whatever is the focal length is same, so it is 2 upon f. And what is that 1 upon f equivalent? It comes out 2 upon f, so f equivalent comes out to be f by 2. So from here f I will substitute as minus 2r. So it is minus 2r divided by 2 is equal to minus r. So I have f equivalent finally coming out to minus r. If I see the option minus r is this is the answer. So r will match with 3, r will match with 3. It's matching now. And the last one we'll try and see, as the only thing remaining is this. So obviously this will match with this, this has to match with this one. We'll see that that S is one convex lens and one plano concave lens. So let us see the option number, fourth option, that is the S1. What is that S1? We'll see. The option number S says there is a convex lens and we have a plano concave lens. A convex lens, double convex lens and a plano concave lens. What is the focal length of this combination? That is F equivalent we have to find. Single convex lens focal length is suppose F1. Single plano concave lens, suppose the focal length is F2, because these two will be different focal lengths. And for this already we have found the focal lengths that are right here directly, because here for plano concave lens the focal length is minus 2r. So for this it is minus 2r. And for double convex lens, the focal length for double convex lens, the focal length is r, that we already calculated. So I'll write f1 equals to r. So now we have this combination of the lenses. Whether this is kept first or this is kept second, that doesn't matter. Ultimately, the focal length is determined by the reciprocal addition of these combinations. So now 1 upon f equivalent, it will be 1 upon f1, that is the focal length due to this, plus 1 upon f2, the focal length contributed by this lens. Now because they're different, I will write the values. 1 upon f1, f1 is r, plus 1 upon f2, f2 is minus 2r. I'll take the LCM, this becomes r, and this is minus I can put. So it is, I write the LCM, okay, I write the LCM as 2r. It's better. Anything you can take, it's suppose it's 2r. So 1r is here, I'll put 1, 2 here, minus, this minus 1 is there, so it is only 1. This you can solve and this comes out to be 1 upon 2r. So 1 upon f equivalent comes out to be 1 upon 2r. From here I can write f equivalent equals to 2r. So for this combination of lens, the equivalent focal length comes out to 2r. If I see the option, as I told you, that for this combination the equivalent focal length is 2r. So this is the answer. So therefore option number 2 is the correct answer to this question. So this is very basically a question based on the combination of lenses. You must know how to use lens maker formula using sign conventions, and with sign convention you have to solve this, and you have to take note that it is a combination of convex lens, concave lens, plano concave lens and plano convex lens. So accordingly you have to use the equivalent focal length formula, that is 1 upon f equivalent is the reciprocal of individual lenses. Okay, thank you.